We're live, babe.
Yay!
Okay, guys. Hey, on today's Saturday live show, I want to go through the process of what I've been doing thought-wise to go through and build this Crete air conditioning cooling core, because it is freaking awesome. And essentially, how I started was just with an Crete block. Can you see that? An Crete cooling block core. It's about 15 inches by 10.5 by 12.25 inches. Now, when you think about it, you think, why Crete for a cooling core? And it's because of the physical properties of it and how it works with water. It absorbs water, it wicks water, it holds water, but only a certain amount until it starts to flow through, so water flows through it. It's also an insulator, and it's also a sink, meaning it not only is an insulation as in a dam for movement of different temperatures, it also absorbs it until it gets to a certain point and then becomes that temperature. So it's a heat sink as well, or a cold sink in this case. So, but how are we going to cool that Crete block? Well, what if we bored some supercooling tubes or holes through the block? And you may be asking, what do you mean by bore holes through the block? Well, that's what I mean. All the way through the block. And I know some people are asking, what do you mean by all the way through the block, Mr. Honeydew? Well, what I mean is all the way through the block. Supercooling tubes. Now, how are we going to use those supercooling tubes and create cold air and get them to sink into the wet Crete and make it cold, so that you have this snowball effect and this never-ending cold air coming through that block? Well, we're going to do it with evaporation. It works similar to an evaporative cooler. Okay? We're going to put a water-absorbing mesh. The air will also flow through inside those tubes. And what are you going to use to do that? Well, how many people have ever been pumping gas or whatever, and they touch the hose on the gas pump or what? Or the metal parts of it, and it's super cold? Why do you think that is? Well, what it has to do with is a differential between the movement of molecules within those particles, between the gas and the metal. Okay? And that same effect happens when water is going through and evaporating. It completely changes, and the molecules move differently, and it becomes cold. That's how an evaporative cooler works. That's the exact same way an air conditioning system works. You have a gas inside of an enclosed system. It goes through an evaporator, a condenser, a compressor. The compressor compresses it into a liquid, pumps it through the evaporator, which it goes through a heat exchanger with air flowing through it, cools the air, warms the gas. The gas gets to a point to where it becomes back into a gas from a liquid, and it does that whole cycle over and over. And it's that differential that makes it work. So what are we going to put in those cooling tubes so that when air flows through them and they're wet, that the evaporation makes them a supercooling, or more efficient than conventional systems even right now? Well, I don't have my prop. Yeah, here it is. No, Wrong one. Oh, here it is. I do. I was hiding it. That's okay. All right. Well, we're going to use finely milled stainless steel as that medium. Now, how did I discover that? Well, I was making foam mates. And when I was making the end guns and I would put that stainless steel in there, I would put one end over a heat gun to kind of heat the end so that I could stretch it over another fitting. And I noticed the air, even though it was super hot, like 800 degrees on one end, it was coming out the other end cold. So those fine bits of stainless steel, not only during the evaporative system do they absorb a lot of cold air really fast, they also, as the air flows through, do a heat sink with the air and make the air cold as it flows by it. So it's super cool. That was not a very good, simple explanation about how that heat sink occurs with that supercooling core. But just remember, anybody who's ever touched a gas pump knows that you could touch any other metal around. Like, let's say it's in the fall, and you'd be fine. But you touch that, and your skin sticks to it. I mean, the next thing we have to do is we have to get air to flow through the block and be pressurized, like that. Well, not only do we have to get air to flow through it, we also have to get water to come down through the top of the block and filter down through it as well. And we have to be able to get these to happen simultaneously. Well, you may ask, what do you mean by simultaneously? What I mean is simultaneously, at the same time. Water flowing down through, air flowing through the supercooling cores. So, I was able to accomplish that. Now, in my first envisionment, as I was thinking about how this would happen, the first mold I put together in my head was super complicated. It was something that maybe the Honey Do Carpenter could do, and I mean, it was on a skill set level that was just way above what would be able to be brought to the mass public. And so, but I brought it down super simple. You're not even going to believe it. I use basically office equipment to build this super efficient, low wattage air conditioning system.
If you guys want to see a sneak peek, you can check out the Honey Do Carpenter on Instagram. There's a little picture of it. It's not completely done, but there's a little sneak peek.
Yeah, and we are getting ready to release all the drawings and everything of it, and we're probably going to have to release the videos in like a 3 or 4 section deal, because there's so much information that is critical, and you don't want to miss, but it would make it way too long to do it all at one time, and it'd be too hard on Mrs. Honeydew to edit it that long anyways. Now, one thing that's super critical on this aircrete block core is we've got to get the water to flow through and absorb into and be held in the aircrete, as well as inside the cooling tubes to wet the stainless steel mesh at the same time. How are we going to accomplish that? Well, what if we did this? What if we put some little, you can see them, little teeny holes, 18 of them from the top, going down through every tube. What do you mean down through every tube? What I mean is down through every tube, just like that. You see those little teeny holes? All that would do is create a path of least resistance for the water. The water is going to be pumped from a reservoir below, up and around on top, and it's going to flow down those individual small 1/8-inch holes, and as it's going down, it'll take a while for it to even get all the way down because it's going to absorb into the aircrete as it's going down through. It's going to be wetting the cooling cores and saturating the aircrete block. And it works good. I mean, take a look at, say, this aircrete block, right? I've got this aircrete block. See, really similar mix that I'm using inside the aircrete deal. And if you look at it, I mean, look how good that just, look at that. It just sucks up that water. I mean, where's the water going? And then I get about 4 or 5 ounces through, and then it starts to drip out the bottom. But that block is way heavier than it was just a minute ago. And it quit dripping as it was wicking out into the rest of it. And so that block is going to remain an insulative deal. How many of you have ever tried to defrost a steak or something and threw it in some cold water? Or even better yet, warm water to do it faster, but you don't want to do it too fast. Well, that's neither here nor there. But that transfer happens when something is wet and in water way faster. We all know that's true. I mean, if you're wearing a coat and it gets wet, it's useless because it gets cold really fast, right? And that's what we want to happen. We don't. Not only is aircrete an insulator, it'll be a transfer mechanism. And so let's start answering some questions and see what's going on here, babe.
Awesome. All right, let's go back to the top.
Tana, hey, how you doing?
Coolo says you keep coming up with stuff. Tana says hi from Caldwell. Looks like James said hi. Barry says hi, Mr. and Mrs. Honeydew. Nice to see. Nice AC you got there. Well, thank you.
Yeah.
Good afternoon to you. Shot Q says. The Maker Show says, hey, how are you guys doing?
Good.
We're doing good, thank you. Santiago says regards from Laredo, Texas.
Awesome.
Well, hi there. I bet it's hot down there in Texas. Harry says good morning from Harry and Brenda in Oklahoma.
Oklahoma, awesome.
Right? All right, Barry says, yeah, but I can understand it. So he's probably talking about when you were going through explaining the stuff, and he was understanding your explanations. Well,
yeah,
that's
that
good.
wasn't.
At least one person did.
I should have just left it as simple. But
oops, I moved the camera. Sorry. Morning, Honeydew family. Well, hi, Lord. Barry says hi, and Brenda, I am in Oklahoma too. Oh, so we have 2 people from Oklahoma.
Awesome.
That is pretty cool. So the Maker Show says I'm headed your way, your area soon, and do you guys need help?
We may.
You want to be put to work? Hey, Kenny Bean says.
Michael Atkinson, morning from Utah. Well, hello.
Magic Rush says, finally got your lives. LOL, you guys are great.
And Michael Groves from Ontario.
Says, morning from Utah, Michael.
Interesting story about Michael. I think he was like our 10th subscriber. I mean, he was like one of the first handfuls.
He was. It's always nice to see him on here, too. So, hi. Coolio says, Instagram or Pinterest. On Instagram right now, the Honey Do Carpenter, we have a little sneak peek. I took a picture and a little video like 2 days ago or something like that. I posted of the air conditioner and put it on
what I'm using to do the form and make it just completely simple and DIY for anybody.
Yeah.
My whole objective is to put the cookies on the bottom shelf and let everybody have some. And so if any part of doing this project goes over, say, a 4 or 5 on the DIY skill set level, then I'm going to have to actually build that out and put it in a package and send it out as a reward. Okay? Everything else, I want people to be able to just say, oh, I can go to Walmart and pick that up for $2 or $3, and, you know,
Right.
I don't expect everybody to make a foam mate because it's a little higher skill set to do that. So,
You know, he has been struggling and down here for hours and hours going through to try and figure out a way to make it a little bit simpler and easier to be able to accomplish this with everyday items instead of hard to find items.
right. I could have done it a long time ago with the hard to find item.
Right? Okay, so Rebecca says, I had a concrete Indian lady on my step. Water from melting ice degraded here. Would it happen with aircrete over time too?
No. Actually, Linda, that's a misconception about concrete. The people think because it takes in water so easily that it is going to freeze and then just explode. And that's not the case. In all actuality, when I was doing quality control for road building and whatnot, if we were doing a test on a load of concrete that came in and it wasn't at least 8.5% air entrainment in it, we would reject the load and tell them they'd have to go add some more chemicals to get that air up in their concrete. You want that air up in there. It isn't like these highways are sealed out there. They're not. They absorb water and they last for years and years and years, and the reason they do that is because of the air in the concrete.
Well, she had a concrete Indian, and over the years it slowly degraded, and she's wondering if that is going to happen.
That's going to happen to any concrete. It depends on how many years. But I think you get a lot of life out of aircrete.
Yeah. I mean, nothing is really ever really permanent.
Right.
That you build. I mean, try plastic scrubbers, they don't rust. Hi from Roswell, New Mexico.
Stainless steel doesn't rust either.
Paul says, love your vibes. Have you thought of an aquarium pump for the water?
Yeah, I already have the pump system and all the fan system. I'll tell you, how am I going to get that air to flow through? It's actually, there's going to be one volume fan, which runs on about 4 watts. It's incredible. You can put this thing on 6D batteries and it runs for 40 hours. So it's one of the highest efficient cooling fans, and you can pick them up for less than 20 bucks, okay? Which is super cool. And that's going to be kind of the volume push fan. And then I found a bilge air pump, which is a blower. And that would be essentially your pressure pump. The reason I came up with this idea is because when I was working in the deep well and irrigation systems industry, we would have pumps that just lifted massive volumes of water. And they were called lift pumps, and they would just get the water up to where it needed to be. They had no capacity to create any pressure, okay, and really suck and blow. And so then we would have what's called a booster pump up there to create the pressure and do your sprinkler systems and stuff like that. I'm just doing the exact same thing with air. I have a volume system that's going to put the volume through. I have a suction system, which is a blower that's just sucking that through and putting out huge volumes of air through those tubes. Also, I have I think it's a 4-watt aquarium submersible little pump that's just going to pump the water up and over and through. It'll pump it way faster than it evaporates. So that's all you need. And there you go.
Danny says howdy. DFW Michael says morning from DFW.
Awesome.
Magic says the plastic scrubbers are cheap from everything is $1 and they don't rust like the SS scrubbers. The stainless steel scrubbers we actually get from the dollar store also.
Yeah, and I've never had one rust. These are not stainless steel. Or I mean, these are not steel wool. They're stainless steel
Yeah, there is
scrubbers,
a difference.
and they do not rust.
Trust in Christ or go the Aircrete Tesla. Plastic scrubbers are insulators, not heat sinks.
And he's right about that. Where stainless steel, because of the molecules in it, beside the water evaporating, are going to absorb tons of cold air. And they're going to hold it, and it's going to absorb into the warmer air that's flowing through it as it works. And that's what makes the whole system work. And stainless steel does not rust. I've had the same stainless steel scrubbies in my in my foam mate as I had from the beginning, and
so do you have an update on the shed project?
Yeah, I do. We've got the walls all up and done. We've been working on this Kickstarter and working on this air conditioning unit.
And we figured you guys got sick of seeing us pour and set walls up. Sorry.
We had a lot of people complaining about that.
Yeah, I mean, that's all we're doing right now is working on the
AC,
shed, and the Kickstarter. So we're like running with our heads cut off. And
I haven't done as much on the shed. And probably if I would have posted it, people would have thought I'd been going through slow. It's just because I got other fires burning that I have to put out and I have to do.
Magic says I meant in the foam mate. So is he wanting us to put plastic scrubbers in the foam mate instead of stainless steel?
Yeah. You know what? I've tried them both, and it's just my view, but I think the stainless steel works better because you can compact them better, and I like them better.
Harry says, hi Barry, Magic, it rusted in mine, turned the foam brown.
You're probably using steel wool.
What is your Instagram name? I can't find on Instagram.
Honey Do Carpenter?
Yeah, I believe it's Honey Do Carpenter. Let me double check.
Check it, babe.
Yeah.
Okay. Would copper scrubbers work better as a heat sink? I don't think so, because there's one thing, put a piece of copper out in any environment. I mean, it's going to start turning green and then brown and corroding almost immediately.
All right, so... And
this is a bad environment for that.
Oh, sorry. Didn't mean to.
Okay.
I did find the Honey Do Carpenter. I looked it up, and it's the honey the little, can you guys see that?
Probably not.
There we go. It has the underscore. No, it's not working. Sorry. But Honey Do Carpenter line do, or Honey line do line Carpenter. If that makes sense.
Is it an underscore or, yeah. Honey underscore do underscore Carpenter. Why did we have to put the underscore between it?
I don't know. But yeah, hopefully that helps. So hopefully you can find us on Instagram now. Would a copper scrubber work better as a heat sink?
I already answered that.
Oh, my bad.
Okay. Have you tried to mix Aircrete in a concrete mixer?
Tana actually posted Honey Do Carpenter. So if you look under Tana, she actually put it there for the Instagram name.
For the Instagram.
So thank you, Tana. Have you tried to mix Aircrete in a concrete mixer?
Yes. I have. Yeah, and it doesn't work. It's really difficult to fold the foam in a concrete mixer. Now I've done the slurry, same theory as like a rattle can, a ball bearing, and a paint can to mix it up. You can mix the slurry in a concrete mixer. It's much easier just to put a mixer in a bucket or in the bottom of a barrel, though.
You got an 80 degree by 10 by 10 room, and you run this thing in the window. What will the room temperature be?
Well, I've already done tests going through these supercooling tubes, and it changes the temperature from one side to the other about 25 degrees. And we were in like a relative humidity of, I mean, it's not very high. We're in the high desert. It's like just 50% or below.
And humidity does make a difference.
It does make a difference, but it works really well. And so, you know, we're going to be moving 130 cubic feet per minute. That's
a lot.
That's quite a bit, 130 cubic feet per minute. I mean, there's 7.481 gallons in a cubic foot. So, I mean, we're talking on like over 1,000 gallons of air every minute. So, in a room that size, I think it would significantly make a differential between the outside temperature and the inside temperature by at least 10-12 degrees, even if the air is coming in.
Okay, so
at
Barry
a 25-degree differential.
is wondering if you think that a static charge could build up and arc out to humans.
A static charge?
Yeah, can you read it right there? It says, do you think that the static charge could build up and arc out to humans? Since we're using stainless steel in there, is there going to be any type of static charge that could build up in that?
No. The thing about static electricity is it doesn't work really well in, I mean, if you ever, like, say you're doing this, you go in your dryer, and your clothes are semi-wet still. They're about half dry. Do you ever get shocked with static electricity? No. It's just not a good environment for static electricity to easily move without being dissipated first into something else that is grounded, which a saturated block of aircrete would be pretty well grounded in the environment. So I'm thinking not.
It looks like James just donated $2, and that means a lot to us. That is
James.
Very amazing of you. Thank you. And he did say a 10 by 10 room at 90 plus air block.
So it was 10 by 10, so about a 7-foot ceiling. So that's 100. So that's about 700 cubic feet. You know, because you've got 100 cubic feet on the bottom times 7. I think it would air condition a room that size phenomenally well. You'd probably have to turn it down on low.
All right, and then Chuck says, morning, can you add color to the aircrete mix? We have been wanting to try that so much, and where haven't you?
I don't know. I actually went and bought the color.
I know. We've had it.
I know.
We will try that soon, hopefully. All right, so James says, so how does the air get the exit hot air get out and get the cool air in, and how is it going to suck and blow at the same time?
Well, you take your form that has all the cooling tubes through it and all the forms down through that, and pour your nice little block that has all those bored holes all the way through it, all the way. But you don't take the form off. And then you just put another extension on each side. Silicone some plexiglass on one side with a fan blowing in. Silicone the blower on the other side, sucking it, blowing it out. And it's awesome. You'll see, it sounds like you're going to follow along on the videos really well.
Much more like an air conditioner than a swamp cooler. I'm saying this because swamp coolers don't process the air as well as this system. Is this true?
That is true. I think it might be something that would kind of revolutionize that particular industry, just simply because the physical properties of aircrete. I mean, you look at it on the heat side, in my insulated stovepipe that I insulated with aircrete, and it doesn't, the air is only 100, 120 degrees, it shoots up that thing like a rocket. I call it my hot air vacuum. It completely changed the game on fluing, because not only does it act as an insulator and hold the heat in so it can't go out, it absorbs the heat and becomes warm itself. And it does the exact same thing on the opposite side in this. It absorbs the cool from the cooling tubes, insulates and holds it in place. And I even have a way to capture more of that energy that is typically lost in a traditional swamp cooler. And that's through a tube system going all the way through it, back and forth. I'm not going to do it on this one. I am going to do a second one as an alternate, but I have to keep this somewhat on the low skill side set level. And I actually yesterday figured out a way to make it kind of a good skill set level that I could put it out DIY, but to capture more of that energy that's lost. And you're saying, what do you mean by more of that energy that's lost? Well, let's say your water's filtering down through. It's just room temperature, 70-degree water. It goes through the aircrete block, through all the supercooling tubes, and by the time it gets to the bottom, it's like 40, 42, 43 degrees dropping into the reservoir. And then it gets pumped back up as cold air again. Well, guess what? All that, anything above like 55, 60 degrees down in your reservoir is just wasted energy, because it works just as well going up in the top and down through on a swamp cooler at 55, 60 degrees as it does being either hot or cold. But I mean, it works on an evaporative deal. So what are we going to do to capture that extra temperature and change the temperature of that water that's going back up from 45 to 60 degrees and get that energy in the house? Well, that's simple. We're going to run our whole pump system through a system of coils through the water. And as it goes through, the water will absorb the cold energy from that cool water. And then it'll go through a heat exchanger with a small fan on the inside of the home. And so it's going to be like a hybrid, actually, guys. It's kind of crazy.
You're amazing. Do you know that?
Right.
All right, so Kulo, it says now they're following us on Instagram. Awesome. James says, so what you're saying is that this thing, you will be the equivalent of a 5,000 BTU wall air conditioner that basically takes about a 10 by 10 room and makes it into an ice box, but that has a way to take the hot air out of it.
Well, anytime you're using a swamp cooler, we're using fresh air outside and bringing it in and cooling it. You also have to have an exit. So it's not the same thing as any type of a 5,000 BTU cooler, which just recirculates the same stale air and just gets it colder and colder and colder. That's not what this does. So it's going to work efficient, like more efficient than any other swamp coolers. Kind of have some characteristics of being similar to an air conditioner, particularly with, here, go grab that for me, babe. Particularly when you add this whole system into the mix and you run water through this heat exchanger that goes through the coil in the reservoir, extracting the cold from the cool water in the reservoir, and then running it through here, and then this extracts the cold out of here, and then what comes out the other side is about 12, 15 degrees warmer, and then that goes back up on top and down through and gets recooled again with the supercooling tube. So it's going to have little similarities of both, but it doesn't have that extreme differential that a compressor would on like Freon or R34-1, whatever they put in these compressor systems for air conditioning systems. It's not going to be that. I mean, you're only going to get a 25-degree differential between the air temperature outside. So if it's 100 degrees outside, and you're outside in 100 degrees, and you have this thing blowing 75-degree air in, I think it's going to do even more than that. I think it'll get closer to a 30-degree drop, but that's huge. That's huge.
All right, can an aircrete pad be made for a swamp cooler?
I don't see why not. I would, anytime you're going to use aircrete, it needs a wear surface, I would put a wear surface on it. If I were going to use it as a subfloor in a house or whatever, I would put like 4 inches of aircrete and then an inch of hardened concrete or tiles or something like that. You're going to want a wear surface.
Barry says, are you using a weed eater cord to make your 1/8 holes through the tube cord?
That's one of my secrets, Barry. What do you... No, I'll tell you. Where'd they go, babe? Oh, they're right there.
They're right there?
Okay, it's... See, that's the thing, guys. I go to Mrs. Honeydew's kitchen and I just steal her stuff and she yells at me.
Yeah, he raided my kitchen again.
Okay. What are those? Huh? Bamboo
Here, hold
skewer stick. Here, just pull one out of the plastic. Bamboo skewer sticks.
Yep.
They're 1/8 inch. Before I put all the cooling tubes in the form, I drilled 3 holes in them in the exact same spot on every one. I made a jig on my drill press. See, that's an example of something that would maybe go above the 3 or 4 skill set on DIY, and something that I'm going to have to add into a package. So all the cooling tubes to go into your form. But it's just a bamboo skewer stick, bud. It's sharp on one end.
But this is one of the things I actually don't mind him taking from my kitchen, unlike my ice cream maker.
That ice cream maker was old, baby.
Okay, as a chimney sweep, I know you are correct. Well said. And it's exciting to have an off-grid air conditioner. Negligible energy consumption.
Well, here's the thing, guys. This thing, you can go buy a 25-watt solar panel for really pretty cheap, and it'll run this thing. It'll run it all day long. It's really cool, and I'm doing it that way on purpose. You should see the blower. I told people about this blower, but I never showed it to them. Bam! Look at that. Woo! This thing sucks it. I mean, it's like, oh, it sucks air. It's awesome. I did it on Mrs. Honeydew, and she was like, oh, her hair was blowing in the wind. It was awesome.
Oh my gosh.
Yeah.
You're hilarious. Did I miss the beginning of the Kickstarter? Paul asked.
No, we haven't launched it yet. Probably what? We're
getting very, very close.
We wanted to do it this week, but
there's a lot more going into it than we thought, and then Mr. Honeydew keeps changing things.
It's so different from my original drawings. I'm almost embarrassed. If I actually did a video and took you through my first drawings of what this was and what I was thinking, oh man, I'm glad I didn't do them videos. You'd probably be like, this guy's an idiot. That's not...
We are getting ready to do it, and hopefully it will be coming out very soon. So, Paul, but go ahead, Paul, and could you send us an email to the honeydocarpenter1@gmail.com? We've been trying to get a hold of you.
The hot air is what is cooled. That's correct. That's correct. But you have to cool something that's going to cool the hot air. And we're going to use stainless steel. And it's going to be cooled by way of evaporation through these cooling tubes. Which in turn is going to create and make the sink into the aircrete block. It may take a while for it to get super cold, but it's going to end up being cold. Now in a traditional swamp cooler, go ahead, touch the top of one. It's cold. And guess what? There's no insulation, there's no aircrete, there's nothing. It's just being lost out to the 100-degree temperature and the sun beating down on the top of it or whatever.
All right, so Michael says, awesome idea. And we're getting 28 degrees in dry southwest Utah. And okay, Barry says.
They're getting a 28-degree differential with a traditional swamp cooler.
Yeah.
I honestly, guys, and I'm going to have to test it over time. This thing is going in Julie's off-grid cabin and going to be run with a solar panel. But I can't wait for the data in. I think I'm going to get between a 30 and 32 degree differential in Idaho, where we're a little bit more damp than even down in southern Utah.
We will see. I'm excited.
We will see.
All right, and so Francisco says, hello, you are great. We'll work on humid climates like in the southeast.
Okay, now that's a good question. Because people say, oh, they're not efficient and they don't work. Even in the most humid climates, you're going to get a 5 to 10 degree differential in the 75, 80, 80, 90 percent humidity. You're still going to get between 5 degree differential. I think because of the elements of aircrete, I want somebody to test it in that environment and see what the differential is between the outside air and what's coming out the other end. I'm thinking it's going to maybe change the game. And if you look at like a United States map of where swamp coolers are used versus just strictly air conditioning systems, because people in the industry said they're not efficient enough to work in those areas, which isn't necessarily true. But I think it's going to expand the map and the amount of people who could use a swamp cooler versus just a high energy sucking air conditioning system that requires 3 high powered motors to even work.
Down East Wave says hello from Eastport, Maine. Well, hi.
Hello.
And Eric says hi. Kuya says, when
can we see a demonstration? Well, I poured the first 4 that I decided to change. But a demonstration of the final one, let's give it at least 2 more days to cure.
Yeah.
And then we're going to set it up in Julie's cabin, and she'll probably have to shut it off at night because it'll get too cold.
So, hopefully soon. Mateo says, can you offer a package deal on your Etsy store? I would like to buy the foam generator with your new head nozzle, and I want to buy one of the air conditioners.
Okay, good idea, buddy. Well, the air conditioner is going to be initially offered. All my drawings are going to be open sourced, right? I want anybody to look at it and be able to watch my videos. I don't care if you're in a third world country and be able to maybe copy this, okay? But the packages for the air conditioner are going to be offered originally on the Kickstarter. After the Kickstarter's over, we'll probably offer them on Etsy as well. And as far as your question about the foam generator with the new end nozzle, all new foam generators are going out with the new and improved end nozzle. All of them. It doesn't matter. The price didn't change.
We only put the new end nozzle, just the nozzle itself, in case people wanted to upgrade the ones they already have, or built the tank themselves and wanted the upgrade. But if you buy a foam mate now,
right,
it comes with the new nozzle.
So anybody who wanted to build a tank themselves or use a propane tank that's old or whatever as their reservoir, all they'd have to do is just for $89 or something, buy the end nozzle, and they could just hook their hoses up to that and go. And that's the only reason we offered it separate. Not because it's not coming with the new foam mates. It is.
Yes.
That's a good point.
Yes. And Mateo says, thank you for your generosity. And Darla Curry says, your prototype relays on a D-cell battery to power the fan, right?
No. It doesn't. I'm just saying this fan can be powered either with a D-cell battery or by solar. It doesn't matter. Either one. It has a plug-in for the solar on the side. I was just testing it to see how long it would actually go on through what was it? 3 or 4 D cell batteries. I think it was. How many does it hold? I think 4. Yeah, 4 D cell battery. And I mean, it's it'll go forever. It's,
right.
Yeah. It's
So
a really high quality.
this gives you an option. You can either do solar or a battery.
Yeah, and guess what? You can also do AC, right? You can plug it right into your wall at your house too. And so this could be on grid or off grid. This is going to be something that in these heat waves that we're having down in New Mexico and Arizona and California, they could put a solar panel out on their back porch and just run it, and that's fine. Or they could plug it into their house, and it's still going to use only a few watts compared to their other air conditioning system. And it might make it so their other air conditioning system doesn't have to work as hard and use as much energy. So.
Right. And Michael says, looking forward to seeing this work in Julie's cabin, and I was impressed with the rocket stove.
Awesome.
Well, thank you. Danny,
Thanks,
smiley faces, and Darla says, nice.
Okay, so.
All right, is that it?
That's it.
All right, you guys have a wonderful day, and keep an eye out for the video coming soon.
Should I show them a sneak peek of the form poured down here? You can see all the skewers going through the portal holes. It's all poured on top. It's completely full.
Nice. All right, you guys have a wonderful day. Talk to you later.